In this lesson, we will focus on the rendering settings aimed at using light groups, a very powerful tool that allows you to substantially modify the lighting of a scene even after the rendering has been completed. We will therefore see how to configure the rendering parameters in order to make the most of this feature, improving flexibility and creative control over the final result. It is important to point out that some rendering parameters have already been configured during the lesson on camera positioning. However, we will go over these parameters again to make sure we haven't overlooked anything and to check if any changes are needed. Let's check that in the Render tab, the render engine is set to cycles and the device option is set to the hardware we have available. In my case, I leave it set to GPU compute. This allows me to take advantage of the graphics card's capabilities and achieve better performance during rendering. Within the Render submenu, we set an appropriate value for the max samples parameter, which is essential for determining the final quality of the rendering, affecting noise reduction and image clarity. In this regard, it's important to note that increasing the max samples value will significantly increase rendering time. Therefore, it's essential to calibrate this value to balance good image quality with reasonable rendering times, also taking into account the capabilities of your available hardware. After some testing, I decided to keep the default value at 4096 samples. This setting effectively utilizes the power of my graphics card, allowing me to achieve high-quality renders in reasonable times. I also recommend that you run some tests with your own renders, adjusting the max samples value according to your system's computing power to find the best compromise between image quality and time efficiency. Still within the Render submenu, let's make sure that the checkbox for the denoise parameter is checked. Let's move to the Color Management panel. Check that the View Transform option is set to AGX and the Look parameter is set to Very High Contrast. Looking at the test render, the resulting image appears quite dark. Let's try increasing the exposure channel value slightly, setting it, for example, to 0.7. Open the Output tab and make sure the image resolution is set to 1920 by 1280 pixels. In the Output submenu, set the path for saving the file. Open the drop-down menu for File Format and select the OpenXR Multilayer format. Set the color depth parameter to Float Full. We choose this image format because it allows us to keep different types of data, such as lights and colors, in separate layers within a single file. This is useful because it allows you to modify specific aspects of the image after rendering, so there's no need to re-render, saving time and increasing flexibility in the post-production process. Let's open the View Layer tab and enable the denoising data parameter. This choice is strategic because if we were to process an already denoised image during post-production, the process would be very slow. By enabling denoising data instead, we can apply the denoising node in the compositor only after all modifications are complete. This allows us to efficiently make the final image sharp, optimizing time and simplifying the workflow in post-production. With the changes made to the parameters, we've created the optimal conditions both for rendering and for the subsequent post-production phase through compositing. However, before starting the rendering, it's necessary to define the categories to which the lights will belong, thus making it easier to manage light groups during the post-production process. Let's stay in the View Layer tab. Scrolling down the menu, we find the Light Group section, which has an empty field ready to be filled with the lights we've added to our scene. To add a light, click the plus button and then double-click on the default name assigned by Blender. Let's rename the light to 01 Butterfly Light. It's helpful to number the lights progressively to keep things organized during compositing. Let's repeat the process by clicking the plus button again and renaming the light to 02 Fill Light. Continue in the same way to add the other 3 lights to our setup. Once the categories are created, we now need to assign each light to its respective group. In the outliner, select the butterfly light. Next, open the Object tab from the Properties window. Within this panel, navigate to the Shading tab and then to the Light Group submenu. Click on the empty field to bring up a drop-down menu, from which you can select Group 01 Butterfly Light. Repeat this operation for each light, assigning them to their respective groups one at a time. Once this is done, save the file incrementally. Now everything is ready. Press F12 or select the corresponding option in the main menu to start the final render. When finished, save the image in EXR format in a dedicated folder. In the next and final lesson of this module, we will explore how Blender's light groups allow you to manage lighting configurations effectively and practically, focusing on how to adjust their intensity and color to optimize the visual impact of our scenes.